Good morning, everyone. So I'm happy to be here and to be invited for a topic related to AI. I have no knowledge, I have no confidence talking about AI. Sorry, so my throat is sometimes demanding these days with the allergy. Okay, so this is my topic. So let's talk about if AI is a Neo-Solow paradox. I think I will have something to say about how to gauge the role of AI in China's growth and productivity. And this is quite ambitious. So I don't think I can say much about it. I'd like to hear maybe sometimes in the conference from the audience. Okay. All right. I cannot read that. That's the problem. Okay, so this is my agenda. I will start from the Solow paradox. So what is Solow productivity paradox? So this is a computer productivity paradox was proposed following Solow 1987's famous remark, computers everywhere but in productivity statistics. So it refers to the widely observed increasing use of computers in the 1980s in the backdrop of a sluggish productivity growth. Pardon me. The paradox was discussed and explored intensively by researchers such as Paul David. His work could be the first one following Solow's remark. And Eric Brand-Joseph, 1993 paper, and later there are some others. Let me use this. Actually, this was cited by Brand-Joseph. So you can see the chart on the left-hand side. So this is the computer as a share of produces durable equipment. So you can imagine that in all the equipment that you use.
This is not moving.
All right, I'm sorry. I think this is my problem. Should remind me. I can see that. Yeah, on the left-hand side of the chart was the computer share in durable equipment. On the right-hand chart is white-collar workers' productivity. So you can tell that, so this tells the productivity paradox. Okay. So what are the major hypotheses proposed for the paradox? So basically, so firstly, we see there are a lot of researchers from different areas of research, management science, information science, and some economic historians. Basically, we see this following maybe mainly 4 hypotheses. First one is mismanagement. Which means that the productivity is not absent, but missing in the measurement. Okay, so there could be missed in the output, input, and the quality. So you may have heard that, like people like Brand-Joseph said. So recently, for AI, so we may need to have a different type of GDP to measure the consumer surplus. I think this is a problem because so if you have a equilibrium view that so in theory that so we cannot only measure that consumer's surplus. So there's other things, the other side of this. So it's not simply like that. But there's indeed a mismeasurement problem. And the second one is time lag. So that is not now, as learning and adjusting to IT take time. Okay, this is easy. I don't have much time to explain. And the third one is a redistribution effect. So that is the gains, it could be canceled out by losses and the lateral impact on the aggregate economy. This could be mixed with number 2, because if you wait for enough time, so this could be something you can see that, right? And the last one is mismanagement. To me, I think it is more an institutional problem. So it requires a change in organizations, legal framework, etc. This is also related to number 2, because it will take time for all these adjustments, supplementary changes in institutions. However, to an economist, particularly for a growth economist, I think we cannot address the productivity problem without a growth accounting framework, because you have to put everything in the same framework. You cannot only pick up several products, services, several technologies, or some industries. You have to think about the rest. You have to think about the impact on some, on the rest. Okay, so it has to be in a coherent framework. So, and next I will introduce the work by Dale Jorgensen. Basically, he does not simply agree with the specification of the Solow model, and he extended, and I will introduce why that kind of extension is very important. So before that, let's get into today's problem. So is today's AI a Neo-Solow paradox? So here we can use the conference board total economy database. It was actually kind of take a heritage of Angus Madison and revise the update and continue. So you can find it from conference board website. So if we use that data, you see we are indeed observing a new Solow productivity paradox. So you just see the recent maybe 2 decades. But wait a minute. Is this really something, a background we can refer to as AI accelerating or industry policy racing? Because the major economies are here. So when major economies are driven to a industrial policy competition, and then so that will be costly, right? So that will be something reflected in productivity, in the decline of productivity. Okay, to simplify what I just showed you, so you can see this chart. So let's see, you can compare the blue one with later the red one, the IT era versus the AI era in TFP growth. So although it's difficult to argue that the AI case is purely caused by the paradox, as I just mentioned, so because of this period, is overlapping with some other factors which could be also powerful. Okay. Oh, I'm sorry. So this is the what I mentioned, the over simplified so I think it is self-explains the issue I just mentioned. Okay. When we come to growth, this is a big challenge. Or when we come to the measurement of growth, is it necessary to worry about how to tell the AI impact on growth, on productivity. What I mean, so is still necessary. So as we have seen that so many things happening, very excited, we feel very excited about those things. But I think for growth economists, so we have to think of the other things, right? I just mentioned that. So we cannot only work on anecdotes. We cannot only work on stories. We have to think about how the resources allocated and reallocated because of the cost, relative cost changes. So anecdotes cannot convince a growth economist. Okay, so how a growth economist supposed to respond to the paradox? So when new technologies rapidly restructure the economy, so we are facing multi-dimensional heterogeneity problems that are not handled in standard models. Okay, the traditional Solow model implicitly assumes that any new technologies, if there are any, so is evenly distributed across all industries. So the industry facing the same factor costs. So there's no concern of using weights to capture it. So that's the feature of the Jorgensen model, right? So he extended the Solow model. So no, we need a new national accounts matrix so that can coherently integrate industry productivity accounts economy-wide. So this we have to mention Jorgensen and Greidich's 1967 paper. They proposed a aggregate production possibility frontier framework and later incorporating DOMA aggregation scheme to extend the original Solow model to integrate industries, and in which used a constant quality index to handle what I just mentioned, the heterogeneity problems. Okay, so let me show you, I'm sorry. Okay, yeah, let me show you what we can get from Jorgensen's results. This is in his 2001 AER paper. This is for the first time using a strict growth theory with his extensions to address the paradox. If you pick up the yellow part, so this is the source of a gross domestic product according to his results, and the yellow part can be enlarged in the right part of the chart. The dark yellow one, so is something because of the IT, the computers, and the light yellow because of the non-equipment investment, the productivity change. So from here we can see that using the economy-wide industry-level data, and now we can see so this is the kind of interpretation strictly using that kind of approach about the paradox. So we can see that there's indeed a Solow paradox. Okay, so you can see the dark yellow part is increasing, as kind of transforming from the early 70s, but we have a period that productivity decline, and then so gradually the productivity comes from computers, from IT increased. So to the basically to the 90s, particularly late 90s. Okay, so next I still have some time, right? Right. Okay, so what I'm going to do is I'm going to talk about the data we use for the Chinese economy. So the topic here is how to address the ICT or digital economy measurement problems for China. Because I believe that when we talk about AI, when we talk about how to incorporate AI into a framework so that we can measure the growth, we can measure productivity, and then so we have to start from ICT. So ICT is a base for adopting AI. Okay, so there are several points. We adopt the Jorgensen framework in principle for the so-called KLEMS type of data. So you can pick up this from Jorgensen's initiative at Harvard. So there's a website on the word KLEMS. KLEMS means K is capital, right? Capital, labor, energy, materials, and services. All this in the network. So and you match this output with all inputs accounts, capital and labor, and also a price matrix. So we reconstruct the conceptual consistency of official data from all sources. So this is something important. Instead of, when we traditionally fix the data problem, we find one particular indicator, and then we try to fix it. So at the same time, we forget the rest. The approach here, what I'm using, and I push students to work on this way, is we have the theoretical framework first. And then we find all data, different sources, we try to fit into that framework. And then we know where are the gaps. And we can actually try different hypotheses to fill the gaps. Okay, now we have 45-year data for the so-called China KLEMS. We have, based on this, we have estimated the ICT asset out of the total equipment, and we're also developing other dimensions. So remember I mentioned that we have a dimensional heterogeneity problem. So we have to pick up all these differences, which means that we have to be able to construct all different weights and find a way to integrate all these weights, use these weights to integrate the whole economy. All right, I know that. Okay, so, and now I just show you some results. So this is the industry contribution to China's growth. Just the industry contribution to growth. There's no TFP. I think you can rate from this big screen. I frame it in the red color for ICT related. ICT producing, ICT using, intensive using in manufacturing, ICT using in services. And then the rest you can rate, right? So basically, if you try to figure out, so ICT has been increasingly making important contributions, but slow down, particularly for the past decade. So you know what I mean, right? Okay, so if I translate the previous table into this chart, this is, I'm sorry. I translate it into this chart. So I show the results from early 90s. So all these different periods, as 7 periods, 6 periods, you can take it as a important policy regime change, right? So the figures on the top indicates the growth rate. Not exactly same as the official growth rate, because I use double deflation to deflate the inputs and outputs at the same time, and officially using single deflation, assuming the price changes in input output in the same way, or same changes. I highlighted the last 10 years with that background indicating AI accelerating. You could also say the industry policy enhancing. So, and the growth slow down. So you can read from the bar. Okay, so and the next one, we see these are factor contributions. Just now we watched the industry contribution and now the factor contribution. So you can easily break down this. The value-added growth or GDP growth comes from capital input. You can further decompose it, and the labor input and aggregate TFP. Okay, so you changed from another perspective. So for the lower panel, so you can see ICT equipment contribution, not big. All right, so because overshadowed by structures, dwellings, which means the housing sector, and for labor is also very interesting. You see that high-skilled labor increase sharply, and the lower skilled and the medium-skilled labor declined also significantly. The TFP shows the last line all the same, so this is from the same system. Okay, so now you see this one. This is the factor contribution. So the numbers on the height is also the same growth rate. So I don't have to say more about this. So if you want to pick up the ICT equipment, so that is kind of the blue, in the second level blue. Okay, so this one is China's TFP growth by ICT specific group. So here, if you remember the first growth table, so that's industry contributions or industry group contributions, and this one is industry group contributions to TFP. But we have three parts. The first one, you see all these industries, and the number two is a reallocation effect of capital, which means that the capital move across industries and the effect on TFP. And the last one is reallocation of labor on TFP. You see the capital reallocation effect has been negative since the early 90s. This could be puzzling many. Okay. So this is about the TFP. So you can see the best time, no wonder, is the period following China's participation in WTO. So the number three. So we got the highest growth in TFP, 2.1. It's a jump from previous period. But basically the 90s are positive. It seems that, because of Deng Xiaoping's further engineering to push for border reforms, so we see all this positive gain. But then, following the global financial crisis, so from the number 4 period, so we see overall the net effect is negative, right? So the background is still the same. So I still read the same question: is this AI accelerating or industrial policy enhancing to cause this productivity loss? Okay, so there are several things. So if we here we can map the TFP index for 45 years. So okay, it's like this. This is the total aggregate TFP. But then, so we can decompose it. We can separate actually from the so-called within and between effects. Within means that from industries, the productivity gain from industries, or from the resource move across industries. So now, you see this chart. We compare to the first one. This one, so this aggregate, and the next one we add. This is from industries. So what is the gap? So why we have a huge loss in productivity? All right. So we have a reallocation effect. So this reallocation effect from labor is very much understandable. We gain from labor reallocation. This is for any developing economies. You gain from labor moving out from traditional sector or agriculture to industries and the services. But this stopped from the early 2000s. So you can see basically become flat out and stagnated. And the next one, and this is very eye-catching. The dark blue is the reallocation effect of capital on TFP. So we only enjoyed a very good time, so basically in 80s, and then so stopped growing, and from 2000s, started declining. It's a time when we actually adopt this kind of grabbing the big, or revitalizing the big ones, and freeing the small ones. Actually, when we joined the WTO, we have enough resources to support the big ones, no matter if they are efficient or not. We keep doing that. So we show this reallocation effect of capital on TFP, the dark blue line. Okay, so almost the end of my talk. Why I show this, actually, so I think this is very important for the data work. And we don't have any systematic ICT data, but we do have equipment data. And if we assume that, so the ICT contribution is picked up by the GDP already, if we trust the official GDP data. So we don't have that kind of data, doesn't mean there's no such thing of ICT. So and then we try to use this kind of logic, and we use the other countries' data, we work out the relationship, we try to separate the ICT. And this means what? So if we, you see the blue line, the light blue line, which means that, you know, both are capital reallocation effect on TFP. When we do not have ICT separated or estimated, and we have a kind of a better picture, which means that there's no ICT, or there is indeed ICT, but the ICT is equally distributed. Just like many theoretical models, we don't take those differences. We assume they are the same across industries. That's why we can have aggregated production function. But when we dig into this, so now we say the dark blue line actually giving us a worst TFP because resources are reallocated to less efficient industries, maybe to big SOEs. But when we do not have ICT, we assume ICT actually evenly distributed across all industries. It's the same as no ICT because no change. But if you bring the change in, we see the effect, which means that, you know, we are wasting a more productive asset, right? So very lastly, what we are doing is we are trying to work on this. So our research center, our growth lab, working with another group of people from NSD, Shen Yan and her students, we started working on the AI patterns. This is very preliminary, so but we do have this kind of and we do have this kind of results to show that the AI patterns, how it's related to this particular industry, this ICT industry, TFP performance. I cannot jump to any conclusion about this. I'm just saying that, you know, so eventually we have to try to incorporate AI impact with a system like this. Very, very lastly, so some ending remarks. Okay, so we are facing this question still. So we focus on anecdotes, stories, some industries, some technologies, some products, or an economy-wide growth framework. We still need this kind of work. So we focus on selected or targeted industries, or also consider the rest, the impact on the rest. So even more important to me, I think policy engineering by reallocating resources has opportunity costs. As an economist, I think we should not forget this. So, and also for the global thing, we know there are a lot of things happening. Speculating we can, so I think major economies, interventionist industrial policies for cutting-edge technologies inevitably drive a global competition, so which is not only costly, but also dangerous. Thank you.